Hello, and welcome once again to Rapidbench. In this video, we'll define a Rapidbench module and show the various ways to create modules for your Rapidbench project test bench. Rapidbench modules represent components that encapsulate specific functionality and connectivity in the project test bench that is created. How the module is physically represented in the test bench created by Rapidbench is determined by both the languages and methodologies chosen for the project and by the module type selected for the project. In the Project Config tab, you select a Design Under Test language and a test bench language with optional methodology. The .dot language selected typically identifies the language of your design modules or entities. Pretty straightforward. Verilog, we expect a module. VHDL, we expect an entity. Should Rapidbench be requested to generate any design files, the syntax used would be as specified by .dot language. Test bench language identifies the language for the top test bench and any test bench files specified for generation and determines the module type selections available for each module. Again, for Verilog, it's a module. For VHDL, it's an entity. And when the modules tab, your types are .dot module and user BFM and test module. The test module shows an implementation of a verification sequence. For system Verilog, again, it's the Verilog module type and what's added, and the Verilog types are shown here, the same ones, .dot user test, and also added is an system Verilog interface, which is usually the front end for a BFM that you want to connect to your .dot. Now, if you do choose a methodology, UVM, you'll get all the system Verilog choices for module type plus UVC, which is implemented as a SV interface for physical connection to the .dot, and along with a number of UVM classes, and UVM component, which can be any of a specific set of UVM classes that support creation of the framework for a UVM verification environment. So let's look at the various ways that we can create a module using system Verilog as our test bench language. And by create, in this sense, I mean identification for Rapidbench and not necessarily creation from scratch. Okay, so the first method is simply to choose a type, enter a module name, and that can be an existing module name, which it is in this sense, and say add module. You can either enter port IO or you can go over and grab it from an existing module, which is what I've done, and paste it right in. This is an existing module. Just show you that a little clearer. And so I'm not going to enable module file generation by Rapidbench. Save, and you have your module created. The second method is to use, again, you want to select a type. You always want to select a type. This is going to, we're just going to call this a .dot module because that's what it would be if we were using it. Say choose file, and you have a window that gets you your local system where you can find your file. I happen to know that this file has multiple module declarations in it, so I'm going to specify the name, better be correct, the name of the module I want to extract, and it extracts it. Gives me just the relevant parts that Rapidbench needs. We're not going to enable module file generation. That would be the default when we pull it from a file. And save. Okay, so those are the first two methods. The following methods are all all happen on the connection page. Now from the modules tab, you're only creating modules. From here, from the connections page, we will also create instances, and in some cases connect those instances. So first let's get a .io. So we have .io selected. Load a module from file. We're going to grab this AXI demo module, which has some AXI interfaces, and we'll load it. And so you see it's grabbed the module, it's grabbed the file, extracted the module, created an instance, and populated it right here. You see it has an AXI master interface, an AXI slave interface, DDR3 interfaces, and a few other I/O. The next method to create a module actually will create the module instance and connect it. So we're going to select some I/O off of this. We're going to select the AXI master interface, and we're going to connect it to a system Verilog interface, which has the slave AXI pinouts. And we're going to say load, and that should extract it, create the instance, and connect them as best it can to the I/O that we've selected. You can see it did a pretty good job. A couple are not there. Did not make the connection. Now what we could do, I'm connecting them manually, but what you could do is reduce this threshold for auto connection and try again, but since there are so few that weren't found, I'm just going to connect them manually. That's really beyond the scope of this video anyway, so those connections are made. And the final method for creating a module, again, creates the module and the instance and connects. But what we're going to do here, well, let me first select a new color so that we can see what happens. We'll select sand. So I'm going to select all the DDR3 I/O, and then I'm going to use this model button to create a BFM in the case where we didn't have one before. I'll call this a user BFM. I'll give it the module a name. And I'll give an instance name. I'm going to say connect these nodes, these ports to the AXI demo, this instance here, and enable module file generation, because we're basically creating a user BFM here, and create. And this should create a module, an instance, and make the connections. So that concludes the module definition and creation video. Tune into other Rapidbench videos for more module creation examples. Thank you.